Can I ask for your attention as we begin our afternoon session, if people are comfortable and ready to begin? Is that okay? And everybody's okay with the sound? We can hear. Good. So our afternoon speaker, for some of you, needs no introduction. Many of you will be very familiar already with Dr. Jonathan Schott, who is a colleague over at the Dementia Research Centre, as you can see from the slide, a reader in clinical neurology, and he has a lot of interesting updates of a sort to give us, but actually also a perspective on PCA more generally that he was going to open to the floor by way of question and answer session. So I leave it to John to take us through his slides, but also to coordinate a question and answer generally at the end of this afternoon. Thank you.
Thank you very much indeed, Jill. It's a great pleasure to be here, to see quite a few faces who I know well from clinic and from research, and to meet some of you for the first time. So as Jill says, I'm a neurologist, and I was asked to give an update on drug treatments. I'm going to not surprise anybody here by saying that I'm not going to have a huge reveal of some new treatment for Alzheimer's or PCA that you don't already know about. But I thought it might be helpful, as clearly what drugs are available is a question that I'll get asked every clinic, if I talk through with you the process by which drugs are evaluated, what drugs are currently available, which again won't come as a great surprise to anybody here, and how are we moving forward with finding new drugs. And then this will take around 20 minutes or half an hour, and then plenty of time for questions, which can be about drug treatments or non-drug treatments or really anything to do with PCA. I'll also preface my talk by saying that I'm going to talk about drugs, and I'm going to talk about drugs for Alzheimer's disease. I'm not going to talk about drugs for other issues related to cognition and to other aspects of living which can affect patients with PCA or Alzheimer's or other problems. I'm not going to talk about drugs for depression, and I'm not going to talk about drugs for bladder. I'm going to talk about drugs specifically for Alzheimer's disease. And I'm also not going to talk about non-drug treatments. And so I don't want you to go away with the impression that I'm a neurologist and I like to give people drugs. I work within the framework of all the people who work here today, and I'm an absolute firm believer that drug therapy can and only ever will be one part of what we can offer to our patients with PCA, with Alzheimer's, with any form of dementia, and the psychological support, the practical aspects, all the other things that are going on here are important, as is the research, which, as we'll see, will guide the development of the new drug treatments. So what am I going to do today? I'm going to talk a little bit, I'm going to give everybody an overview, a rather sobering overview about how are drugs developed. If we want to take a new drug, because people will say, oh, I've read something and it's usually in the Daily Express and there's a new drug coming and, you know, when's it going to be available? And actually, just to think through how we do develop new drugs. I'm going to talk a little bit about what drugs are proven to help, and I'm going to talk a little bit about what treatments are not proven to help. And then I'm going to talk a little bit about where we're heading when we're moving forward. And as I say, some questions at the end. So, everyone wants a new drug for Alzheimer's disease, and I'm going to talk mainly about Alzheimer's disease because it's the commonest underlying cause of posterior cortical atrophy, PCA, but what I'm going to say goes for most of the other causes as well. So how do we test a drug to see whether it works? Well, first of all, we've got to have some idea of what we're trying to target. We need to have some idea about what the causes of any disease are, and therefore to try and design rational treatments. And that comes from lots of different sources. So that will come from some of the genetic research that's being done in this area. It'll come from some of the work that some of you have and will be helping Zainab with, so looking at the brains of individuals who've got Alzheimer's in different forms. This will come from the development of some of the work some of our colleagues do, taking brain cells and growing them up in dishes, or looking in mice models and trying to understand the biology. And then ideally we will target medications that will be specific to try and prevent that particular pathology that causes Alzheimer's disease. So you can see this is a complicated process. And once you've got a target, you then need to design some sort of medicine that will interfere with that process, will disrupt that process. And that's a prolonged process. And once you've done that, you'll need to see whether it's safe. And so it will usually be given to animals, to rodents, to see how it fares in a living organism, how safe it is, before we can even start to think about giving it to human beings. When we've got a drug, it will then, go into what's called phase 1 studies. These are the first in men. And we say men because it usually is young men, usually students, who are fit and healthy, and usually not women because everyone's concerned about potential for childbearing in later life. And these individuals will come to facilities and will be given the drugs under incredibly close supervision in small doses and build them up to give an idea about not whether the drug is working, but how it gets into the body, how it gets into the brain, and if it's safe. And once those experiments are done, then we'll go for a phase 2 trial. So this is when, for the first time, it will be given to patients with a particular disease. And again, these phase 2 studies will be looking to make sure that it hopefully does what it's supposed to do, but not to prove that it's effective, but to give some information, which will then allow us to go on and do what we call phase 3 studies. So these are the very large studies that need to be done before a drug can get licensed. And these studies will have a number of characteristics. First of all, they will normally be more than one study. So before a drug is licensed, it'll often be several large studies. They will be done in more than one centre. So we want to make sure that this doesn't happen just to work for people who live in Britain. We want to make it so it'll often be international, often in the States, in Europe, in multiple centres. And that also gets the numbers up fast. These are the studies which will be given in a very controlled manner. So what we call a placebo-controlled trial. And some of you will have taken part in these studies. So this is when you get given a drug, and you don't know whether you're being given the experimental drug or a placebo, which looks exactly the same but does not contain the active treatment. And neither does the investigator. Those of us who run those trials, we don't know either. It's only the companies who will know that. So this is done in a double-blind fashion, meaning that the patient doesn't know what they're getting, and neither does the doctor. So we keep this completely unbiased. And these are hugely expensive and lengthy trials. And then if those are positive, then a license can be granted, which means you can prescribe them. And then the situation is, fine, we've got a drug that's been licensed, can we give it to people? What happens if some of the new therapies that have been launched in the States for some genetic conditions cost £100,000 a year? Is that appropriate? Can we roll those out? So then those go to from the licensing authorities to the more practical aspects. So many of you will have heard of NICE, or the National Institute for Clinical Excellence, who will then look at all the evidence and say, is this cost effective? Can we give this fairly to everybody who will need it? How do we go about giving it to the right people? And then afterwards, and this is an ongoing, and in fact most of you will be taking one drug or another, and we have an ongoing surveillance. And so we're always on the lookout for unexpected side effects. And it can be the drug is launched, as has happened, and then within a couple of months of being used in the real world, somebody develops liver problems. And that can be enough to stop a drug, because of course even in the largest trials that we've done, maybe 1,000 people will be given the drug. What happens when it's given to 10,000? Then you can see whether there are really rare side effects. So this is a very, very complex and long process, which is why people talk about pipelines of drugs, but actually the drug pipeline looks a bit, for those of you that can see it up there, a bit more like a funnel with a huge number of experimental drugs that start at the top, and very, very few that filter down at any one of those stages. And there hasn't been a new drug that's been licensed for Alzheimer's disease for over 15 years. The average time from the start of development to launching a drug is 10 years, and the average cost is $2.6 billion. So this is not by means of being sobering or depressing, but to explain that when we see a highlight on the news that something works very well, that's all very well, but we also need to think about this whole infrastructure, which is absolutely necessary that we give drugs that are proven to work and that are safe. And so, but this is why when people come and say, why can't I get hold of this drug? Well, this is the process that needs to be gone, and it all comes down to the research side of things. So if we think about Alzheimer's, and again I'm using Alzheimer's as a surrogate for posterior cortical atrophy because it's the commonest cause, aside from providing support and looking after people and advice and so forth, what are the sort of drug targets that we have? Well, in very broad terms, what we think is occurring in Alzheimer's disease and other forms of neurodegenerative disease which lead to PCA is that we get abnormalities of normal proteins. So normal proteins in the brain start to crumple up and to misfold. And this is a very prolonged period over many years, and it causes brain cells to die. And then the brain cells which communicate via brain chemicals, those chemicals diminish, and that leads to the symptoms. So if we think about what medications we have at the moment, they are all targeted at this bottom end here. They're all targeted at the brain chemicals, so right at the end point of that chain. And those medications that are licensed are ones that I'm sure everybody will be aware of, and they form into two groups. There are a group which are called the cholinesterase inhibitors, of which there are 3 types, and they are all more or less the same: donepezil, galantamine, and rivastigmine. Some of them are given once a day, some twice a day, some with patches, but they all have the same mechanism. And then memantine, which acts via a different mechanism. And what does NICE say? So what are we allowed to prescribe? Well, it says that the cholinesterase inhibitors can be used for the treatment of mild to moderate Alzheimer's disease. It doesn't say PCA particularly, but we now incorporate that. And memantine can be used for moderate Alzheimer's disease or in individuals who can't tolerate one of the cholinesterase inhibitors because of side effects. And they say that combination therapy isn't recommended, so taking those 2 classes of drugs together. Although I was involved in some work done by one of the European guidelines, which suggest actually that sometimes they can be helpful together. So several of you who have been my patients will have had a trial of the 2 of them together. Again, there was a huge amount of problems, and some of you may remember this, prescribing the cholinesterase inhibitors many years ago, because they were around £1,000 a year, which doesn't sound hugely expensive, but if there are 700,000 people with dementia, with Alzheimer's in the population, that's a lot. Now it's come off the license, and now it's a matter of pence a day, so for the cholinesterase inhibitors. So I think we are much more liberal, as we always have been, but I think we're finding the GPs are much happier to think about that and therefore trying some of these combination therapies. How do they work? Well, this is about the worst possible slide to show at a PCA support group meeting. But basically, nerves need to communicate with one another. And the way they do that is by releasing chemicals. And this particular chemical is called acetylcholine, and it's the molecule that sends messages from one nerve cell to the other. And in Alzheimer's disease, that neurotransmitter, the acetylcholine, is reduced. And so what the cholinesterase inhibitors do is that they block that chemical being broken down. So they increase the level by stopping it being degraded. And that's how they all work. What are their side effects? So they can give a bit of diarrhea or nausea, some cramping of the muscles, fatigue. Some people get insomnia or vivid dreams. Some people can get slow heart rates, and some people can get a runny nose. And these are all because of these chemicals. Acetylcholine is not just in the brain. It's used for nerves to communicate throughout the body. So it's basically interrupting the nerve communication in the nerves to the stomach or to the heart, etc. Now, as many of you all know, these are usually not too much of a problem. And if we use the old medical adage of starting starting low and going slow, and we slowly build them up, most people can get used to them and tolerate them. But that's why some of you may have had an ECG or a heart tracing, or we're interested in taking your pulse when you come and see us, and those are the sorts of side effects that we're on the lookout for. Memantine acts in a slightly different way. Again, the mechanism isn't entirely known, but what it does is to alter how another neurotransmitter called glutamate and actually stops the build-up of that chemical within the synapse, which is the gap between the nerves. So it acts in a different way. And the side effects, again, I think memantine is usually very well tolerated, but it can cause constipation, drowsiness, headache, or dizziness. I will say that if you look at the side effect profile of paracetamol, you probably would never take it as well. So I think one needs to be a little bit careful about that. I think it's worth saying about, because I get asked so often as Saul, there is no convincing evidence that vitamin E helps, ginkgo biloba helps, Chinese medicine helps, or homeopathy works. Okay? There are no clinical trials. The medical profession is not trying to keep things from you. These have been tried and tested, and there is no evidence that they work. Often people will come to me and say, should I take X, Y, or Z? So my view is, I don't believe in homeopathy. I think the science is flawed, and I don't think people should try it, not least because it costs a lot of money. Chinese medicines, I am very anti, because some of them really do contain some rather poisonous stuff. In terms of most of the other things, you want to take vitamins, you want to take ginkgo, you want to take selenium, my view is it's absolutely fine. I have no problem in people trying other things, but people need to be aware that there is no evidence that they work. And when people, as with all drugs, there's a risk-benefit ratio, and I think the risk that needs to be built in, and some of you who come to see me as patients will have heard this before, the risk is also to your pocket. And there are plenty of people who will happily sell you rather complicated combinations of vitamins at large cost without evidence that they work. So if you want to take a multivitamin, as I do, go and buy it from Boots very cheaply. It'll give you a lot of vitamin E. You can probably have some ginkgo in there if you want as well. But it's important to know what does and doesn't work. And I think it's equally important for the medical profession to tell people when things aren't proven to work, as showing what we do. And we also are aware, of course, that what we have to offer in terms of pharmaceuticals is really very limited, and it's extremely reasonable. And when I and my loved ones are unwell, I will look for things that I can do as well. So I am very well on board with all of that. But at the same time, watch your wallet. So if I've said that in this pathway of medicines, we're targeting that last pathway, the loss of the brain chemicals, what we'd really like to do is go right to the top and prevent these proteins from misfolding and prevent the brain cells loss, to go target things as early as we possibly can. And so what we're particularly interested in is those abnormal brain proteins that accumulate in Alzheimer's disease. And so this is some work that we've done, just to show you some examples. What we really need to know for this for certain is to look at the brains directly, as our colleagues will do in neuropathology. But now we're beginning on a research basis to use some imaging tools to look at some of these proteins. And on the left, we can see in red is the buildup of beta amyloid, which is one of the two core proteins that accumulate in Alzheimer's disease. And on the right, in the black areas, we can see the accumulation of tau, which is the second protein. And this is, these are actually images from one of our study participants. On the one from our right is from somebody who's got PCA. And if you look where that black area is, you can say that it's at the back of the brain. So that is the posterior atrophy. When we know there's atrophy, we're showing that that protein, tau, is accumulating there. So we're now using these new techniques to get insights into how the proteins are leading to the cell loss, which is leading to the symptoms in individual cases. But in terms of what we're trying to target, the main targets have been against beta amyloid, but we're also thinking about targeting this other protein, which is called tau. And so in terms of our drug targets, what we're aiming to do, the various targets, first of all, we'd like to prevent the accumulation of this abnormal amyloid, and if it's there, to clear it away. And we might be able to prevent it by blocking the metabolic pathways that lead to its accumulation, and we might be able to clear it by giving vaccinations, so injections. And there's lots of trials going on trying to vaccinate people against these abnormal proteins so they will be cleared. Similar approaches for tau to prevent its build-up or to promote its clearance. And then we know that inflammation with the brain is likely to be playing quite a major part, so blocking inflammation. It's sobering that if one goes back to my pipeline and the number of drugs that are coming through, that all of these drugs have failed in their studies so far. So these are several drugs trying to clear amyloid, several trying to stop its production against inflammation and various others. And there were two very big studies, and some of you may have been involved in these studies with bapineuzumab and solanezumab, which hit the headlines, very promising treatments which failed. And bapineuzumab is no longer in trials, solanezumab is still being evaluated. So there are some, whilst these are all very sobering, there are some hints for optimism when we move forward with clinical trials. First of all, this is a study of drugs that are in development that could launch in the next 5 years. So despite there being quite a few failures, you can see that there are, so the dark red for each of them is when the trial's going to be completed or estimated. The blue is when they will try and file with the regulators, and the lighter pink on the right is when, if they work, they might be launched. So you can see that there are still quite a lot of drugs that are in various stages of development. And there are some particularly exciting drugs that are being launched at the moment. And this is a drug that has again hit the headlines fairly recently called aducanumab. And these are those amyloid scans that I showed you at the start. And on the left-hand side at the top and the bottom, at the top is before treatment and the bottom is after treatment. We've got people treated with placebo when there's no difference. And you can see that as the dose gets higher, particularly on the right, if you compare the top right panel to the bottom right panel, these drugs are definitely engaging the target they're supposed to, and they are removing that amyloid from the brain. Now, these are very early, those phase 2 studies, and there are very large of the bigger, better controlled phase 3 studies going on. But we do have drugs that are hitting the target. Whether that's the right target is not clear at this stage, but we have got target engagement, and there's a lot of optimism about some of these trials that are ongoing at the moment. And I've said that we want ideally to prevent these diseases, and if we think that that abnormal protein accumulation is going on over years, if not decades, there are a lot of studies that are now starting in people who have very mild illnesses, or ideally being treated before symptoms even start if we can identify individuals with a view to trying to prevent these problems. As always, it's far better to treat an individual who comes into their GP practice with a cough with an oral antibiotic than waiting many years down the line until they've got a nasty pneumonia. So as with everything in medicine, early treatment is likely to be better. So what about PCA? Well, currently, we recommend the treatments as we would for, I would say, normal Alzheimer's disease in inverted commas, but for memory-led Alzheimer's disease, unless we think there's another cause. And for those of you who've had PCA that might be attributed to other causes like Lewy body disease, the treatments are much the same. And we are actively aware that PCA would fall into what we might call an orphan disease. So common enough to have support groups like this, but rare enough that it's difficult to do these very big trials. And we're also aware that many patients with PCA may not be eligible for clinical trials because people will go through their tick box for Alzheimer's disease and says, bad memory, oh, doesn't fit, not entry for our studies. And so there's quite a lot of work that's going on, and we are doing quite a lot of work now internationally to try and draw together groups with interest and expertise in posterior cortical atrophy some of you will know we published our first international genetic study in PCA, which brought together people from 10 different countries. Seb Crutch has just published the first ever international consensus criteria for PCA. So we're all talking a common language now, which means that that sets the stage for recruiting to bigger studies, to drug studies. So we are moving forward with that. And so whilst I cannot give you, I'm afraid, any definite answers at the moment, all I can say is that we are working on it. So I will stop there, and I'm very happy to take any questions. I think we want people to use a microphone. And actually, before I start, I feel like the Eurovision Song Contest, I have had a question sent in already.
Please don't start singing.
And the question actually, which I hope we probably answered, was asking about runny nose in PCA. And the question was, could this be related to the medication? And the answer is, as you'll have seen from my earlier slides, it certainly can be due to the cholinesterase inhibitors. In terms of how worrying a symptom is, I don't think it's a worrying symptom. It's clearly a rather unpleasant symptom to be having. And in terms of trying to ascribe it to a cause or a consequence of medication, this comes into, I think, the risk-benefit ratio, which is, does the risk of or the annoyance of having a runny nose outweigh being on the treatment and any benefits that it has. If the treatment hasn't worked, it may be worth discussing with your doctor stopping, because if the runny nose, if it's not helping and he's giving you a runny nose and that's an unpleasant, then it may not be worth carrying on. And of course, there's also the perception of what a runny nose is and how unpleasant it is to the individual. So that will be my comment on that. Fine. Hands up for microphones, please. Whoever has a microphone can speak. Yeah.
You said that it wasn't recommended to take memantine and galantamine together. For a PCA sufferer currently taking both, my husband, which would you recommend would be the better to take?
I would recommend you do carry on both. So there are guidelines. There's the spirit of the law and the letter of the law. So, and I think we've produced the guidelines that, so these are, of course, every country does their own guidelines. The NICE guideline says don't do them together. The European Academy of Neurology guidelines, which I was involved, showed that it wasn't harmful, and for some people it had a benefit. I would not, if you're on both, I would stay on both.
Is there any?
Yeah.
1, 2, 3. Yeah.
Yes, yeah.
Is there any suggestion that tau and amyloid buildup are in fact effects rather than causes, caused by inflammation due to other sources such as diets and various foods?
So the link between inflammation and neurodegeneration is very interesting. I think there's unequivocal evidence that amyloid and tau are pathological in their own right. I can give you some evidence for that, but suffice it to say that rarely there are individuals who have mutations in genes that either cause too much amyloid or too much tau, and they will get disease regardless. So there's no doubt that the two of those proteins together can cause pathology. What we think is that inflammation may well be a link, which is linking some of these pathways together. So if you start accumulating proteins in the brain, your body may well mount an immune response against that. And sometimes that might be good, clearing it. Sometimes it might be bad, sort of the friendly fire, and actually cause more problems. But it's important to say that I think we, and that's doctors as well as lay people, use inflammation very broadly. Inflammation is hundreds of different pathways with hundreds of different molecules. And there's a lot of work now looking at specific parts of inflammation and how we could target them. But it's not like, let's just take an anti-inflammatory. There is some very weak evidence that certain anti-inflammatories taken earlier in life might influence things later on, but it's very weak. We certainly wouldn't recommend that for the time being.
And sorry, one other quick
Yeah.
one. Is there any further thought about the causes of PCA or more widely Alzheimer's? Why do some people get it and some people not?
So it's a very good question. I can give you a very trite answer to start with, which is we know the biggest risk factor is age. We know that for any complex disease, any disease state, it's going to be a combination of your genes and your environment. We now know there's 20 risk factor genes for developing Alzheimer's disease. So there is a genetic basis. This is not the same as it running in families. This is a genetic risk, and it's likely to be certain environmental factors that come together as well. We are currently doing a very big bit of work looking at this in a large number of individuals and trying to tease this out. We've shown in our international genetic study that the genetic risk factors for PCA are slightly different than those for more traditional Alzheimer's disease. And it may be, and this is all very provisional, some of the genes that we've demonstrated as risk may influence how the brain is wired together even during development. And so the questions are, what causes it, and then which part of the brain does it affect? So it's something to do with your genes, something to do with your environment. We're moving ahead a little bit with this, but we don't have an answer, and certainly not for PCA at this stage.
Yes, hello. You mentioned that PCA is an orphan. Yep. Now, if I'm a big pharmaceutical company and I'm head of the research division, I could look at the numbers of potential PCA sort of sufferers, yep, and I can sort of deduce that the numbers are so tiny. Would it be worth my while in the research division to actually research and put funding and a huge effort behind such a very, very tiny number of people?
It's a very, very good question. So you can take the nihilistic view and say no, or you can take, as we do, the optimistic view and say yes, but huge advances in pharmaceutical science have been made by studying very particular groups. And one of the problems with drug trials is taking a very varied group of people. And sometimes there is huge power in taking a very, very closely defined group and targeting those individuals, and that can give major insights into the wider population. So if I say, you know, PCA is really fairly extraordinary. Most people will have Alzheimer's disease. Most people will get their symptoms somewhere between the ages of 50 and 65, some people older. That's very unusual. At the ages of 50 and 65, most people don't have vascular disease in the brain that will happen earlier on, so it's maybe a rather purer disease. This actually may be a very specific group which we could use in a very small studies to try and demonstrate the proof that our drugs were targeting, which then might move on to other factors. In other words, there may be some huge benefits in using a very specifically and very well-defined group, not only for that group, but because it might give insights into the disease more generally. And that's certainly an approach that the pharmaceutical companies are very interested in, because understanding the spectrum of disease and the modifiers of that may be very powerful ways of understanding the more typical later onset disease as well.
Do you have any evidence that would tell us how long these drugs continue to help with the symptoms? And do you get to a point when they're no longer helpful?
So the answer is yes, there is good evidence, and this was produced in a large paper which was coordinated by a psychiatrist called Rob Howard here. The evidence is very clear. You continue taking the medication, because at one stage when people got really quite severe, there was questions about whether medication could be stopped, and he showed in a very large trial that hastened the time to nursing home. So the answer is you continue the medication, particularly the cholinesterase inhibitors should be continued. The memetine's a bit less clear, but for the cholinesterase inhibitor, there's good evidence you shouldn't stop it, unless side effects get in the way.
Oh, hello. Oh, thank you. You had mentioned that PCA is genetic. Have you seen any proof that such symptoms can apply to children?
The first question relates to genetics, and it's important that we try and distinguish between genetic causes of the disease and genetic contributions to disease. So there are some conditions where someone has a faulty gene which causes a condition. classic example of that is Huntington's disease, which is always genetic. If someone has Huntington's disease, they have a faulty gene, and their children then have a 50-50 chance of inheriting that gene. Okay, so that is a genetic cause. There are very, very rare cases of Alzheimer's disease that are caused by a mutation. To our knowledge, there is one reported case in the literature of PCA running in families, and we're a bit skeptical about that. So I think the answer is we do not believe that PCA is an inherited condition, i.e. goes through the generations. Aside from genetic cause, there's genetic risk. So you'll have a number of genes, for example, that will determine how tall you are. There's not one gene that says you're tall or short. There'll be lots of different genes in combinations that will say whether you're taller or shorter. And there'll be lots of different genes that will modify your risk of developing Alzheimer's disease. So there's a difference between genetic predictors, you will get this, and genetic risk. So that's question number one. So we don't know of any causes that will go between the generations followed strictly. In terms of the relationship between early life vision problems and PCA, there's some interesting work which is looking at some people who have labelled as having sort of visual dyslexia and problems early in life and whether that might be a risk. I think the jury's out on that. The issue with vision problems is, of course, problems with your front of your eye are phenomenally common. Looking around, how many people are wearing glasses, how many people of you will have glaucoma, those diabetic problems. In other words, that problems with the front of the visual pathway, so the eyes themselves or the retina, are so common, and PCA is so rare that it's unlikely that there's a strict relationship between the two. Of course.
Oh, sorry. Well, I don't really understand all this, but the basic question is, does it reduce lifespan?
What? Which? So none of our
PCA.
Yeah. So none of our medications will affect lifespan. So these are all affecting the brain chemicals at the end. So they are not affecting lifespan. They are at the now we're working as we move further up my pathway.
Yeah.
We would then hope to have more major effects on in terms of prognosis and prediction. At the moment, the drugs that we have are related to helping the symptoms.
Okay. Thank you.
If PCA is supposed to be so rare, how do we actually know that it actually is so rare when at the moment there's supposed to be this international study? We don't actually know. I mean, medical people don't know what PSA is, so what chance is there for us to know how many people are out there and whether or not it's something that's going to get more plentiful, and is it something to do with possible environmental conditions as well?
So it's an extremely good question, which of course is that we only know about the cases that we know about. Absolutely. So there's a few things to be said about that. First of all is that by bringing together some international consensus about how we diagnose this is a really important first step, because we all need to be speaking the same language, which we weren't before, and I think the work that Seb has spearheaded from this will be very, very important. Secondly, I would entirely agree that we need better epidemiology, we need better scoping out of individuals. We are taking some efforts to do this, and again, some work that Seb's done and I've been involved with, Tim, who some of you know, and Keir, is to produce some information for optometrists. So in fact, everyone goes and gets their eyes checked, so we need to inform the people who are on the front line when you have your glasses about this. So there's some work going on both to neurologists, ophthalmologists, and opticians, because the problem is recognition, not ascertainment. In that almost everybody is going to get their eyes checked sooner or later. The question is, when you go, does the person on the front line recognize it? So there's a lot about education. there's no question, as I've spoken at these PCA support groups over the years, when we ought to be, before we could huddle into a small cupboard, and now we're in the welcome, that the word is getting out there. The fact that there are now international PCA groups, now that we have got these international consortium, there's quite a highlight of this in the neurological literature as well now from the research perspective. Seb and I founded there's the International Alzheimer Meeting, which for the first time ever is in London this year, and we now have an atypical Alzheimer's disease professional interest group, which brings together a fascinating array of people, from pathologists to neurologists to geriatricians to optometrists to occupational health people, everyone now coming together to look at these more atypical forms, and particularly PCA. So yes, it is almost certainly under-recognised. I think that we have a lot of ways now that we are getting the recognition up, and the more we're speaking a common language, the more we can investigate some of the aspects that you're asking about the epidemiology and the causes. I think we'll have one last question, I think, just to finish up. Yeah.
The drug pills that are under development at present for the prevention or clearance of the proteins, if you think of the 6 or 7 stages of PCA, will those drugs be effective at all stages, or are they only effective at the early stages?
It's a very good question, and again, I think if we were fast forward in an ideal time till we have the drugs, if you think, many of you will have been affected or know someone who's been affected by cancer. No one gets given one drug for cancer. You get given different drugs that are targeting different aspects of the process and are varying at different stages. So the answer is, I think when we know if these drugs are having effect, we'll be able to know what would be the ideal stage to give them. I think you're absolutely right, though. It's likely that the drugs against amyloid will work better earlier. It may well be the ones against tau and inflammation will work later. We're still going to also need those that modulate the brain chemicals that we have now, and we need better drugs to do that as well. So I can imagine we're going to have a very targeted approach across, and this is going to be, and everything is moved, there's lots of buzzwords going around at the moment about personalised medicine, you know, and actually the same, if you've had cancer or someone's had cancer, this day we will target exactly which sort it is, and you'll have a personalised treatment that works for you. At the moment, we don't have the drugs to do that for dementia, let alone for Alzheimer's disease or PCA, but in due course one could imagine a targeted array of medications that work for Alzheimer's and some specific ones for PCA. I think that would be our hope. So I'll stop there, and thank you very much for your attention, and then I'll pass over to Seb.
John, thank you so much. That was really informative and helpful, and I particularly like the fact that this audience keep you on your toes, because the questions were so hard. You actually created a new job title there, ophthalmologist. I'm not sure actually exists. So amazing. You've created a whole new discipline by the kind of the integrity of your questions. So thank you. Roberta, do come and join me. It's now our sadness but our pleasure to close the meeting by embarrassing as much as we can, within the bounds of social niceties, Jill, who, as many of you will know, is about to take a 6-month sabbatical and is stepping away from rare dementia support. And then we will very much look forward to welcoming her back in the autumn, but in a different role with the Dementia Research Centre and the Created Out of Mind project. I think I first met Jill, well, Jill's got a much longer history with the Dementia Research Centre than I have, but had a long-standing role in leading, as then it was called the PICS disease support group, which became the FTD support group for people living with dementias which affect the front of the brain, and also supporting the language support groups. But then I think in about 2010, I think Jill came on board to really spearhead and lead the PCA support group, which was at that stage still quite a small and cosy gathering. And as you will know, since then has developed the broader umbrella organisation of rare dementia support, and overseen the introduction of 2 entirely new support groups for supporting people living at risk or affected by familial Alzheimer's disease and familial FTD. And in that time, Jill's dedication and responsiveness to the questions and uncertainties and life situations that people were bringing to her has meant that she hasn't just kept it as it was. She's not only built the size and the impact of the meetings here in London, but she's developed regional support group meetings for a number of those groups in close working partnership with many of you. She's seen the development of the newsletters, getting the whole enterprise onto a much more professional footing, and has also not only overseen the development of individual relationships within the support groups and developing things like the buddying scheme, which I know have been, today I've had 3 or 4 conversations in which people have said quite how valuable having connections with other people who've really walked that path before have been for them. But also taking rare dementia support and the issues affecting people living with rarer dementias onto a national stage with Jill representing rare dementia support in a number of national and international bodies and organisations. Before I blather on and embarrass her further, I'd asked Roberta to come up and say a few words about what Jill's contribution to rare dementia support has meant to her and Noel. And one of the reasons for inviting Roberta, other than that she's a fantastic speaker, is if I'd invited anybody, if I'd made it open mic, I know the queue would have been down to the end of the seminar room. But for the moment, Roberta.
Thank you. I'd just like to say such a big, huge thank you to Jill. In the time I've known her for about 5 years now, when Noel was first diagnosed. And I think what you all are experiencing here today is what we felt in all that time. Is she's always there to support you, to guide you, to, if she doesn't know the answer to something, to point you in the right direction. And the strides that she's taken with this group and the other rare dementia support groups has been phenomenal. And I think, we owe her a huge debt of gratitude for doing that for all of us, because it's made a huge difference in all of our lives. And will continue to do so with what you've started, Jill. So thank you very much. We're going to miss you.
And just to encourage you and reassure you, you're not being left in the lurch. Jill, in her utterly selfless style, has put in a lot of work in preparing the support for the next few months. And in planning for the future. And we're delighted that Rachel, who many of you I hope are getting to know, and Jeanette, and many of the rest of the team, along with myself and John and other members of the Dementia Research Centre and the Created Out of Mind team, will really look forward to continuing to hold these meetings, to build friendships, to build relationships over the coming months. And I think it's very much au revoir rather than goodbye. I'm sure we'll be tempting Jill back, not just for the sandwiches, but because I know we won't be able to keep her away from seeing you and continuing many of the friendships that she values so much. Rather than me blathering on, I think Jeanette has a little something for you, Jill. If you could come up so we can embarrass you one last time, that would be great.
Thank you. What can I say? We're out of time, almost. We're not. How's that happened? Nice try. Okay, so no, it has been and remains an absolute privilege, and I don't say that kind of glibly or sort of without real meaning. I think I'm very fortunate to have been able to do a job for this long that actually I have loved and I know is a part of me. My heart is utterly engaged in the work that we do within these support groups. I wholeheartedly believe that we have a worthwhile and a valuable contribution to make together to our experience. My head is fascinated by the way that PCA and the other rare dementias affect this concept of perception that we so take for granted when it works so well, but which so quickly compromises our worlds when it begins to fail in any way. And I guess my spirit and my soul speak, I hope, a language of love and connection that kind of give us just to walk alongside each other as human beings in this journey that is life, is the most special thing that we can do for each other. So on all those levels, I've had the best job in the world, and I really hope to continue to work together with you going forward. Thank you. Back to business. We are. The slide, again, I make no apology for showing the slide that we show at the beginning and the end of every meeting, because it conveys that message, which I hope is true to the remit of these meetings, that whilst a lot changes and a lot develops in the places that we meet and the research that we talk about, the key and the true and the most important reasons for meeting together are because there is an invaluable exchange that happens when we meet together and share that which makes us human together in places like this. I said at the beginning of the meeting, we all approach these meetings with different expectations and different hopes. We've had two very different speakers, and I hope that at whatever level you were hoping to glean something from today, you've at least managed to tick some of those boxes. We say always take what's helpful and leave what isn't, and if there's anything that needs clarification, speak to us at the end or email us later. But on every level, we hope that it has met a need of one sort or another. And bang on 2 o'clock, it just remains to say wish you a safe journey home, and obviously we'll send information about the next meeting as and when that's ready. Thank you.